So today we start the third lecture of complex number. So there is example. The point Z1, Z2, Z3, Z in the complex plane are the vertices of a parallelogram. In order, if and only first one is Z1 plus Z2 equal Z2 plus Z3. Second one is Z1 plus Z3 equal Z2 plus Z3 is Z1 plus Z2 equals Z3 plus Z4 and D is none of these. So firstly, how we show? There are 4 points in a complex plane. So, and this will be a parallelogram. So we have a parallelogram like that. Suppose this is A of Z1, this is B of Z2, this is C of Z3, this is D of Z4. So just treat this complex number as in vectors. So treat complex number as vector. So ABCD is a parallelogram if AB equal BC and AD is parallel to BC. Okay. So now AD, this implies AD vector will be equal to BC vector. So this means that AD is Z4 minus Z1 and BC is Z3 minus Z2. So from this we get Z3 plus Z4 equals Z1, Z4 plus Z2 equals Z1 plus Z3. So it means the B option is correct. So just use the concept of vector. And in the last lecture we have studied about the distance between two complex, which is if there are two complex numbers, suppose this is A, this is AZ1, this is BZ2, so it will be Z2 minus Z1. So likewise here we find AD and BC and we get the result. So now we move to next. Show that the origin and the points representing the roots of equation Z square plus BZ plus Q equal 0. Form an equilateral triangle if T square equal 3. So let Z1, Z2 be roots of Z square plus PZ plus Q equal 0. We know sum of roots. So this means Z1 plus Z2 equal minus B upon A, that is minus B. And the product of roots, that is Z1, Z2, that will be C upon A, that is Q. But it is given that the condition for equilibrium T square equal to 3Q. So just put the value of P and Q here, so we get Z1 plus Z2 whole square will be 3 times Z1 Z2. And we solve it, we get Z1 square plus Z2 square plus 2 Z1 Z2 equal 3 times Z1 Z2. So this implies Z1 square plus Z2 square equal 3 times Z1 Z2. Okay, so if you want to find Z1 square, so Z1 square will be, it is simple Z1 Z2. So it will come Z1 Z2 minus Z2 square. So from here we can take Z2 as common, so we get Z1 minus Z2. So it means we obtain that Z1 square by Z2 will be equal Z1 minus Z2. So if we take the modulus, so Z1 minus Z2 will be Z1 square by Z2. We interchange means if we find Z2 square, so just interchange the value of Z1 and Z2 in this equation. So interchanging Z1 and Z2 in equation 3, we get Z2 square upon Z1 equal Z2 minus Z1. We know that modulus is shared. So from equation 3 and 4, we obtain modulus of Z2 square upon modulus of Z1 equal modulus of Z1 square upon modulus of Z2. So it will come Z1 whole cube equal Z2 whole cube. So this implies Z1 equal Z2. If we put this in equation 3 and 4, so we use this in equation 3 and 4. So means putting this. in equation 3 and 4. We get Z1 minus Z2 will be modulus of Z1 equal modulus of Z2. So it means that the triangle formed by origin Z1 and Z2 is equilateral triangle. Thus, the triangle formed by origin Z1, Z2 is equilateral. You know that the equilateral triangle have all its sides equal. So these are the sides of equilateral triangle. Since if one vertex is origin, other is Z1, and one is Z2. So first will be Z1, this is Z2, and this is Z1 minus Z2. So if all these vertices are equal, so all these sides are equal, so we can say this is a equilateral triangle. Now we move to next. Exam next question. A, B, C, D, E are points on the complex plane representing complex number Z1, Z2, Z3, Z5 respectively. Z3 minus Z into Z equal Z1 minus Z2 into Z. Then prove that triangle ABC and triangle ODE are similar. O being origin. So it is given that there are two triangles like this. A, B, C and O, D, E. So its vertex is Z1, it is Z2, it is Z3, it is 0, it is Z4, it is Z. Okay. Also here the relationship is given. So by the given relation, Z3 minus Z2 upon Z1 minus Z2 equal Z5 upon Z4. We can write like that. So we can write Z5 as Z modulus of Z5 minus 0 and this is Z4 minus 0. This is Z5. Now this is Z3 minus Z2, that is B.Sc. Z1 minus Z2, that is AB. So it is that B.Sc upon BA equal Z5 minus 0 यानी कि OE upon OD. Also, one implies argument of Z3 minus Z2 upon Z1 minus Z2 will be equal argument of Z5 minus 0 upon Z4 minus 0. So this implies angle between BC and A. This is the angle between BC and AB. And this is the angle between OE and OB. This implies angle B equal angle O. So you know that these two sides are equal, one angle is equal. So by the convention, side, angle, side, these two triangles are similar. So from equation 2 and 3, this implies that triangle ABC and triangle ODE are similar. So I think it is clear to you. Okay, so now we move to next. Take the complex number. Z1, Z2, Z3. Vertices of an equilateral triangle. Z0 being its circumference of triangle. Then proves that Z1 square plus Z2 square plus Z3 square equal to 3Z0 square. So just go to the solution. Since triangle is equilateral, so its of sides are equal, and there is a relationship for equilateral triangle. Z1 square plus Z2 square plus Z3 square equals Z1 Z2 Z2 Z3 plus Z3 Z. Now we know the center of unity of triangle H. Centroid of a triangle Z1 plus Z3 Z2 plus Z3 by 2. Sorry. Z1 plus Z2 plus Z3 by 3. But the but for equilateral triangles, Center for gravity equals center. So this is Z0 and this is equal to Z1 plus Z2 plus Z3 upon 3. So 3Z0 equals Z1 plus Z2 plus Z3. Scaling both the sides, so what we get? 9Z0 square equals Z1 plus Z2 plus Z3 whole square. Now we open it, then we get 9Z0 equals Z1 square, Z2 square, Z3 square plus twice of Z1, Z2, Z2, Z3 plus Z3, Z1, and this is equal to this one. So just put here, means we get 9Z0 square equal, this will be the of Z1 square plus Z2 square plus Z3 square. We use this equation in this. So we obtain 3Z0 equal Z0 whole square equal Z1 square plus Z2 square plus Z3 square. So this is an answer. Now we move to next. Find argument of I times H plus Iy if argument of X plus Iy is L. Solution. We observe that I can be written as e to the power I pi by 2 and argument of Z1 into Z will be argument of Z1 plus argument of Z2. So just apply this rule. Now argument of I into X plus Iy will be argument of I plus argument of X plus Iy. So here argument of I is pi by 2. So this will be pi by 2 and this is alpha. The answer is pi by 2 plus alpha. Now we move to next. Some properties of mode. So there is a theorem. The modulus of the product of two complex numbers is the product of their mode. So you can see the proof. Z1 modulus of Z1 Z will be equal modulus of Z1 times modulus of Z. We have to prove it. Now Z1 modulus of Z1 Z2 follows. We know modulus of Z square means Z Z1. So we can write Z1 times Z2 or Z1 times Z2 bar. And so it will come Z1 Z2 and this is Z1 bar Z2. Now we can write Z1 Z1 bar into Z2 Z2 bar and this is modulus of Z1 bar Z1 square. This is modulus of Z2 square. So from this is Z1 Z2 whole square. Now taking square root both the sides to be Z1 Z2. Modulus equal modulus of Z1 into modulus of Z2. And